Today we're going to look at this function. F of x is equal to this quadratic expression. Now this quadratic expression is in the form of ax squared plus bx plus c, which is often referred to the quadratic form, standard form of the quadratic expression. Now, one of the things we're asked to do every once in a while is to determine the vertex of a parabola. Well, if we have a parabola and it's opening like so, let's say, this point here at the bottom, its lowest point, often referred to as the minimum, is the vertex, and it would be some y value along the y-axis. And if you recall in other lessons, we said y is often referred to as k. So k would be what the vertex is in terms of its y value. Now, the x value would be our letter h. And we said often h, k can be used in giving an ordered pair. Now, what we're asked here is, based then on this formula, the quadratic form, we want to find what are the coordinates of the vertex. What would be h and k? Well, we have a way of doing it, and for this we convert the quadratic form into the vertex form. And this is done through a process of completing the square. So the first thing we do is to write this where we take our c term and temporarily move it over here. Now, what we're asked to do then is to take this part of the quadratic form and complete the square. Now, in a previous lesson, we said that when we start to complete the square, we want to make this eventually into a perfect square trinomial. Well, the procedure is the x comes down here, this sign comes there, and then we take half of our b term, which is 12, so half of 12 is 6. And then what we do, in order to complete the square, we square a negative 6 and get a positive 36. But now we've added something to this expression here that makes it different from what it was originally. So what we do, where we've added 36 here, we're going to subtract 36. So 36 minus 36 is 0. So theoretically we have the original, but we're just putting it in a different form. Now, this part, when we do factor it, it becomes a binomial square. And here, we're now going to do our addition. A negative 36 and a positive 38 gives me a plus 2. Well, would you believe then we've converted from the quadratic form to the vertex form? So we can pick out from this formula what the h value is and what the k value is, and that is our vertex. Now, a key to this is when you pick your h value out, what was it originally, so that when it went in this form, it became a -6. Well, in order for it to become a -6, originally it had to be a +6. And our k value is right there as a 2. So again, this is not the graph of this particular point. This is just to illustrate a parabola. So this parabola, if we were to sketch it in, would have a vertex at 6, 1, 2, 3, 4, 5, 6, and would have a y value of 2. So that parabola would probably look something like this. Now, another interesting point is, whatever your h value is here, this happens to be your axis of symmetry. And this is the minimum point. Now, one other thing we might mention, just as in passing, is that if you have an equation that is quadratic, but your a term is negative, it's a negative a, or a is negative, then your parabola opens downward. If your a term is positive, then it's like these. The parabola opens up. Okay, just a short lesson on comparing the two formulas. This is an interesting one to have, and a way to find the vertex.